the customer where we earned a lot of business. We would give it out for free, and they would only use it
Mhm.
per case, per client, so per patient. So this was an SUD,
Okay.
and anytime there is a single-use device, you have to sterilize that product,
Yeah.
and that's exposed to just intense amount of laser or that sterility thing. How we attain that? It makes the
Mhm.
plastic brittle over time. It makes the plastic brittle because then
Okay.
then you have to assign a shelf life to it, because once you sterilize a plastic, you experience brittlity over the years, and
Mhm.
because of that sterility process, plastic became brittle, and it was increased noise that it was a customer complaint. In short, it was a customer complaint that we had to tackle. And
Oh. Mhm.
idea is, how do you bring down that noise, because it's too loud, because the plastic was trying to spin because it had gone through a sterilization process.
Yeah.
And then pretty much we did a root cause analysis, and then we did a
Mhm.
pre-DV. Pre-DV is just pretty much before you do an actual design verification, just to get a
Yeah.
sanity check, we perform pre-DV.
Okay.
And in the root cause analysis, we found that because the sleds are made out of plastic, and let's see, this was a while back.
Mhm.
One second, okay, I'm pulling up my resume.
Sure.
Which project are you looking at for this one?
Yeah, it's the last page of your job portfolio.
Oh, it's my last page. Okay.
Yeah.
Oh, motor drive pullback sled. Is that the one you're talking about?
Yeah.
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 Yep. So yeah, we performed the extensive lab book note study. We did a problem analysis, root cause analysis, and we found that because of the plastic, we were getting this noise, and the solution was to add a lubrication to the moving parts
Okay.
in the sled.
Mhm.
And since it's a medical device, it's not that you just take any lubrication off the shelf and apply it. We have to search for medical grade no tox grease. It's pretty much grease, what we
Mhm.
apply on other moving parts. And then we did a
Okay.
noise study by using a dB leveler, like dB level machine, like a product, and
Mhm.
we put it in a
Mhm.
quiet room and do the pullback to understand if we actually decrease the noise or not, which we successfully did, and then the complaints actually disappeared. We no longer had complaint after we released that product again.
Okay. Okay, that's great.
Mhm.
Okay, and so this product's upgrade is what you're working on right now.
No, so what I'm working on right now is actually the electromechanical piece that goes on top of the sled, which is called a
Okay, yeah.
motor drive. Mhm.
Yeah, okay. Okay, perfect. And so, okay, so this is the latest project you are working on. And other than that, if we go back to the job portfolio, so the first one is EU Medical Device Regulations, MDR. So yeah, this medical device regulation. So yeah, what was this project all about?
So this is a project that I was on, but I was later taken off, and because I had, I guess, other projects to work on. But long story
Yeah.
short, what I do have a familiarity of what the EU MDR is, because I was the one who had
Okay.
sort of kicked off the project.
Mm-hmm.
This is a corporate initiative. So anytime a
Mm-hmm.
European Union or European Medical Device Regulation (MDR), Europe
Mm-hmm.
is one of the strictest, uh, I guess, continent or markets for us to deal with, because usually they have the strictest regulations out there. So
Mm-hmm.
pretty much MDD, which is the Medical Device Directive, was converted to
Mm-hmm.
medical device regulation, where they enhanced all the requirements on how strictly the products are labeled, what kind of materials are being used, if materials are
Mm-hmm.
completely banned, if they're not banned, how much percentage of uh, toxic materials you're allowed to have in it, if it's a patient contact
Mm-hmm.
or non-patient contact. So we pretty much have to
Mm-hmm.
take every single product that we own in our division, not corporation, but in division, because every
Mm-hmm.
division was assigned a project manager, an R&D engineer, a
Okay.
supplier engineer, and then we were supposed to do an entire component scrub from product to product down to like a glue or down to like a screw. And we have to reach
Oh.
out to all the suppliers and understand that, do you guys meet these MDR regulations? And pretty much that's what this project was about. And in fact, if we look at the my internship time, I think it's probably listed on
Yeah.
the my resume. It was pretty much the same
Yeah.
project, which is RoHS, the Restriction of Hazardous Substances. It was a similar project, except
Uh-huh.
EU MDR went not just at a component level, like lead or other polymers, but EU MDR is down to the labeling. How do you inform a
Uh-huh.
customer or a patient that this is a medical device and this is not a medical device? So then it came down to the symbology that you add on a label, updating all the directions for use, DFUs, the instructions we find in a product when we usually open a box. So that requires all that of update. And I was the lead R&D engineer assigned for a few months until somebody else took over, because this project was more like a paperwork. So my manager didn't really find
Yeah.
value in keeping me on this project. So then later I was taken off him, and then I took over this full-back project.
Okay. Okay, that's great. But was that project completed successfully, since you were the one who kicked it off? So yeah, I would like to know if it was completed successfully, and if it's over or if it's still in progress.
Yeah, this project is actually a 6-year long project.
Oh
So
yeah. Mhm.
March 18 is when we were kicked off, when we kicked off the project from our division. However, EU MDR, anytime a regulation looks for any change or upgrade, they have to give every company, this is not just Boston Scientific, but every medical device company gets affected by this regulation. So they have to give a
Okay.
company enough time to catch up with all the products and any design change that requires. So every design change requires a design verification. Every verification
Yeah.
requires a design validation. And because it's a medical device, sometimes SUD products require to have a accelerated aging. Sometimes it needs what's the real-time aging, which is like one year, 2 years. For example, on single-use device, if we claim that this product will last for 1 year on shelf, then we have to, depending on what kind of justification, we have to actually test those products at real time and keep those catheters on shelf for 1 year, and then test them to see
Mhm.
that actually function the way it's intended. So I'm just giving you an idea to
Oh
why this project lasts for so long, because when we claim something from a shelf
yeah.
life perspective, we have to actually test it at a real time aging.
Okay.
And
Okay,
but
that's
how
perfect.
Boston Scientific and my division broke this project down is we broke it down by priorities, that which products do we actually ship in Europe? Can we, and what kind of expiration date of a MDD that we currently have, that we can say, okay, you know what, this product can wait to be converted to MDR. But long story short, by 2025, every product that goes out from Boston Scientific has to be MDR compliant. Otherwise, you cannot do any business in Europe. That's pretty much what it comes down to.
Okay. Okay, great.
Okay.
Okay, and then there is this Pixis IVUS link. Yeah. So in this, you were the NPD mechanical design and lead and more.
Yes. So this project, it's supposed
Mhm.
to be the state. This project is about redefining IVUS system, intravascular
Okay.
ultrasound system.
Mhm.
Currently, it's known as the Polaris or Polaris, Polaris, Polaris system.
Okay.
Uh,
Mhm.
so iLab MMGS, iLab Multimodality Guidance System. And the idea of
Mhm.
Pixis is to revamp the entire product line, like the entire system. Like pretty much this is a legacy product. This is about 20-year-old product, and we want to make it state of the art. And I was assigned as one of the new product development, NPD, mechanical design lead. And then I was also assigned a technical project manager, which handled the workflow of this system, and then form factor, along with user interface from a software perspective and from a physical product, mechanical or human factor perspective, usability.
Okay.
And I was not exactly developing these things. Rather, we had hired a consultant who was going to help us with the human factor and form factor and user interface. But I would be the one leading the project from that perspective, because I have a product knowledge from a legacy perspective, and my role was to feed this information to the consultant and then be like pretty much the clinical development engineering position that I want to go for. This is pretty much what I was doing in this project. And this is how I discovered that this is where I want to be, because this project gave me that idea of that, okay, you know what, this is what I really enjoy.
Yeah. Okay, great. And so what was that the legacy project was, the legacy product was lacking, that, you know, you people decided to go for an upgrade?
Yes. So in order to utilize the existing legacy IVUS iLab system, we had approximately 11 to 12 components, which required two PCs, which required one monitor with one transformer. And then we had the keyboard control panel. We had the motor drive, the one we talked about. Then we had the sled, which is the pullback sled we talked about. And then we have the catheter, right? So we have all these components. Without all these components, there is no such thing as IVUS system.
Yeah.
So we wanted to take all these 11 components and turn it into something very small, because customers don't like having a lot of hardware footprint into the cath lab, because cath labs are meant to have more space open because they don't want to trip over a wire or a cable. So we wanted to decrease footprint of our Boston Scientific iLab system, because there are also competitor products out there that we have to accommodate for. And in order for us to stay competitive, we had reached the point. Actually, one of the driving factors of this project is such a legacy product that a lot of components were going end of life. It's EOL, right? So when you have electrical components, there are such old electrical components. Sometimes manufacturers just stop supporting them, so they no longer upgrade their components. So we can't upgrade our components or our product. And eventually you hit a roadblock, just like a wall. You hit a wall because nobody supports the components you have been using for the last 20 years. And we were reaching to the point where we were having trouble finding components we need. So there was a project called Project Mercury, where we took our V2, version 2 computers, PC, and we developed a V3 PCs just so that we can keep up with the end of life issues we were consistently facing. And because of having so many components to perform IVUS, and because of having such outdated boards and resistors, capacitors, and motherboards, and microcontrollers, right? I think technical team and the upper management realized that, you know what, it's time to get to work and revamp this entire product. And that's what the IVUS Link Fixes project was about, which is about what we are obviously in that project is in exploratory / TDP phase. TDP is technology development process.
Okay.